In this lecture, we're going to talk about moderation in structural equation modeling. Now, when I talked about mediation, there were quite a few things that were different in doing mediation in SEM than it was doing in SPSS back when you learned it in multivariate statistics. Moderation, there's really not anything much different other than rather than doing a hierarchical regression with multiple blocks, you're just going to run a structural equation model using the tested model. So I'm going to go over again for you to review all of the steps in moderation analyses and then show you an example of a moderation analysis, which is also included in your readings. So as a reminder, a moderator is all about a variable that actually impacts the strength of the relationship between your IV and your DV, where a mediator impacts it through that. So in a moderation analysis, we're going to be testing that relationship, a variable that actually impacts the strength of that relationship from X to Y. So once more, moderation in layman's term, as we begin with this relationship, X and Y, X impacts Y, or X is highly associated with Y. And then we're going to take a moderator, which actually alters the strength of that relationship. So for example, a psychotherapy may reduce depression more for men than for women. And so we would say that gender moderates the causal effect of psychotherapy on depression. When we are looking at moderation analyses, it can have two kinds of effects. So classically, normally when they're talking about moderation, they're talking about a weakening of a causal effect, but moderation can also amplify or even reverse the association between two variables. Complete moderation would be absolutely reducing that relationship between those two variables to zero, so where we completely remove that relationship. However, in social sciences, we're typically not looking for a moderator that's actually going to eliminate that, but rather we're looking for buffering effects and protective factors and amplifying factors. So we're looking for things that may actually make things better. For example, may make treatment outcome more effective, or may be weakening that relationship, which would be protective factors, things that can reduce the impact of adverse negative child experiences on relationship functioning later in life. So statistically, when we're talking about moderation, we're really looking for a third variable that affects the zero order correlation between those two variables, because it's actually going to impact the level of that correlation as the moderator changes in values. So it's safe to say that testing of interactions is at the very heart of theory testing in social sciences. Our understanding of couples and families, and also of therapy, can be dramatically improved with the addition of information about under what circumstances those may change. So when an intervention may be more helpful or less helpful, and oftentimes the moderator is also our intervention. Like for example, if we're looking at the adverse childhood effects and its association with marital functioning, communication functioning, those kind of things later in life, a moderator can be something that we want to intervene with in order to help reduce that relationship. When we are testing moderation in SEM, I've showed you the conceptual model, which is here on the left, where we have M going straight down to X and Y. When we test it in SEM, the model on the right here is actually what we test. So if you remember from multivariate statistics, we're going to take our predictor and a moderator and create an interaction term, predictor by moderator, and we're going to have all three of those regressed onto our outcome variable. So when we're doing an N+, we're going to test this model right here. So we're going to have outcome variable on predictor, moderator, predictor by moderator. So like I said in the last slide, this slide here just shows you how we are testing that in SEM. So now I'm going to review the steps to conducting moderation. We talked about this back in multivariate statistics, but I'm going to go back through this once more and show you what maybe there's only a few things that are different. Otherwise, it's pretty much the exact same as you did in multivariate statistics. So step one, start with a really good theory. Theory is the foundation of everything we do, and especially in moderation analyses, you have to have a really strong theory about why you believe this can actually affect the relationship, the strength of that relationship between your independent and dependent variables. The next thing you want to do is check statistical power. So moderation analyses can be underpowered because of the way that the interaction term works. And so we want to make sure we have adequate power. when we're doing that. And again, error is compounded in moderation analyses because of the interaction terms. Step 3 is to appropriately code all categorical variables. So if we're using any categorical variables, such as gender and race, make sure that we either dummy code them or effect code them or contrast code them. Step 4 is then to transform our predictor and moderator variables by either means centering them or transforming them into z-scores. Doing z-scores is the preferred method in my book because it's really easy to do and really quick to do, and there's no difference whether you're doing mean centering or z-scores and reporting your results and in conducting the analysis. Step 5 is then to compute the interaction term, so you create your interaction term. And then step 6 is just to test your SEM model. And I have here an example of a tested model as well as the syntax that you'd have on your model command line. Then step 7 is to interpret those results accurately. So when we're interpreting those results, we want to use moderation language when we're doing that. So we'll use that language of like, in a moderation, that's that third bullet point or fourth bullet point here, that like when we're interpreting this, we're interpreting it as the other covariates by 0 and conditional effects when we're doing this. And I'll talk a little bit more about the language that we use here on these next few slides. So when we've centered them or standardized them, 0 is now the mean, and because we have already standardized them, we're going to be reporting the unstandardized results. So when we're conducting a moderation analysis, we don't need to ask for the standardized results because they're meaningless. We already have them because of the fact that we've standardized those variables. The last thing we do is we plot the interaction term. So in this slide, I have working Excel files in here that were provided by Taylor and Francis. This is by Durchi and Solosky and the authors that have the chapter that you have to read. And so there's a working Excel file here that you can use to plot your interactions. So these next few slides go over how you actually do these things. I'm going to talk about how you actually compute your moderating variable and all of those pieces. So remember that after we've have a good foundation and we've cleaned our data, we're going to create our standardized variables. And we're going to do this so that 0 is our mean and that we have a standard deviation of 1, so that when we're multiplying these together and when we're comparing these, they're all on the same scale. So to do this, all you have to do is go to Descriptives, Statistics in SPSS. And then when you go to run your descriptives, just click that check mark on Save Standardized Values, press OK, and then you'll have your standardized values. And it'll have the name of the variable with the Z in front of it. And then when you create your interaction term, you just want to make sure you use those Z-scores. If you remember from multivariate statistics, a lot of you made the mistake of using the original variables to create your interaction term rather than your Z-scores, your Z-scored variables. And you can check those by running your descriptives, and you can see your predictor and moderator that have not been standardized versus the Z-score ones. Now to create your interaction term, you can either go through the drop-down menu and go to Compute, and pull in your 2 with an asterisk in between them, and that's going to create it. You can call it whatever you want. For clarity for me as a researcher, I often like to call it pretty much exactly how it is. So, Z predictor by Z moderator. So I know clearly that that's my moderation term, and sometimes I'm doing multiple moderators in analyses, so I want to make sure that that's very descriptive in its name. And then when you hit OK, it'll then create your interaction term for you. So alternatively, rather than going through the drop-down menus, if you wanted to do this more quickly and also have your syntax to remember how you did this and making sure that you did it correctly, you just do compute your predictor by moderator and then equal Z, make sure you're using those Z-scores, your predictor by your moderator, the little asterisk same times, execute and run that, and you'll have yours. And if you go to your data window, you should see those 3 new variables, and you'll see that they go from, their values, you'll see there's lots of decimals because they're Z-scores. And if you run the descriptives and double check them, you'll see that 0 is the mean when you do that. Now here on this slide, I talk about the language that you use when you're writing this up. So when you're using that language, you want to say, use those words: buffers, protects, exasperates, depends on, is qualified by. You want to use moderation language when you're reporting moderating results. When you're interpreting those results, again, you want to be accurate in how you're reporting those results. And on this slide, we went back through this in multivariate statistics, so I'm not going to spend a lot of time on this, but this gives you a few examples of how you do, examples of language when you're reporting your results. So now I want to show you an example of moderation. This is from my own paper that was recently published. It finally hit the journal in July of 2020, so July of this year. I'm going to show you here the model that I ran with the syntax, the tables, the figures, as well as the results. So to start with, this was a dyadic analysis. So this is the conceptual model. The circles and squares here do not relate to manifest or latent variables because this is just a conceptual model. Rather, the squares and circles are meant to kind of indicate that I have male and female matched partners in here. And what I'm doing in this paper is looking at the relationship between frequency of gaming and its relationship with dyadic adjustment. There's a lot of research that has been really mixed, showing that how often somebody games may or may not positively or negatively impact dyadic adjustment. So dyadic adjustment is all about a relationship process of satisfaction and a few other things in with that. And so we hypothesize it's not actually gaming. What actually accounts for the differing results we've been seeing in the research is acceptability for gaming. And I wanted to do this dyadically to look at both men's and women's gaming and men's and women's acceptance and men's and women's reports of dyadic adjustment in committed relationship. So again, this is just the conceptual model. When we get to the tested model here on the next slide, you'll see this is the model I'm actually testing in M+ when I'm running my model. So here is the tested model. You'll see here that I actually have 4 moderators. This is because I'm doing a dyadic analysis that I have 4 different moderators. So in dyadic analysis, which we'll be going over here shortly, there are actor and partner effects. So actor effects are me on myself, so my independent variable on my dependent variable, and then partner effects are me on my partner and my partner on me. So because of that, we have 4 moderators. We have the self-to-self, so we have men's gaming and men's acceptance, women's gaming and women's acceptance, and we have 2 self-to-partner, so men's gaming on women's acceptance and women's gaming on men's acceptance. So I have 1 independent variable and 1 dependent variable, but because this is a dyadic, I'm looking at that independent variable for men and women, that dependent variable for men and women, and then I'm creating 4 moderators. And then dyadic adjustment I assessed as a latent variable. So you can see here in my model syntax, those first 2 lines are creating the latent variables. So I have F dash, so that's female dyadic adjustment by female cohesion, female consensus, female satisfaction, men's, and then I do the same thing for men. And then I have my my main model syntax, which I'm only going to have 2. Basically 2 lines because I have men's dyadic adjustment on, and I'm going to do all 4 of my independent variables and 4 of my moderators. And I'm going to do the same thing for women. And that's all that I had to write for my syntax. Now, when I did this model, I also had about 25 control variables. So those were tacked on the end here, but in order to show you this a little bit more simply and to kind of show you what this looks like, I didn't include the control variables in this example here. And then here is the table that I reported. So you can see here, all I did is because I had 1 dependent variable, which was dyadic adjustment, I could simply split this into 2 main columns, women's dyadic adjustment and men's dyadic adjustment as my 2 dependent variables, and then have my exogenous variables, because I didn't have any mediators or anything in between them. I just had my IVs and my DVs, and so I could report it in this way, which is a little different than you saw in the example I gave you last week, because of the fact that the example I gave you in the last one, there were, mediating variables and there are multiple dependent variables. So this is how I did it in this way. And again, I'm only reporting the unstandardized results because this is a moderation analysis. You don't report the standardized results. So I have men's acceptance, women's acceptance, men's gaming frequency, women's gaming frequency. So I have my moderator and my independent variable, and then I have my 4 interaction variables. In order to make this easier for the readers, I bolded the significant results. And then you can see in the note, I have my model fit indices. I have outlined any abbreviations I gave and what the full name of those abbreviations are in that note there. And then I also have my p-values. This here is the figure. Because I have 4 moderators, I have 4 figures. So I carefully label each of these figures to show you what it is. So what the interaction term is. So men's by women's acceptability, men's frequency by women's acceptability on women's dyadic adjustment. And then I also labeled these A, B, C, and D because I'm using those labels in my report when I am talking about this in the results. So here I have the written results of a portion of that. So in this, you'll see this first paragraph, which introduces the hypothesis I'm testing here. And then I talk about the 2 actor interaction effects, which were not significant. And then I talk about the partner interaction effects, which were significant. And you're going to see in the language here how I wrote about this, where I said, the association of both men's and women's gaming frequency on their own reports of dyadic adjustment were moderated by their partner's acceptability for gaming. And then I say C, B, and C in figure 1. So if we go back to figure 1, that's B and C there. And then I say, in other words, the relationship between men's gaming frequency and their own dyadic adjustment was negative when women had low acceptability and positive when women had high acceptability. So in my moderation analysis here, this was one where actually I did experience that total reverse effect, where it went from negative to positive or positive to negative. So there I say C, B in figure 1. So that sentence refers to that figure B right there. Men's frequency by women's acceptability on men's dyadic adjustment. So I say in there, the relationship between men's gaming frequency and their own dyadic adjustment. So my IV and my DV was negative when women had low acceptability and positive when women had high acceptability. And then I say the same thing next about C. So C is women's frequency by men's acceptability on dyadic adjustment. So I say the same thing here. Similarly, the relationship between women's gaming frequency and their own dyadic adjustment was negative when men had low acceptability and positive when men had high acceptability. So that's how I wrote up these results to try to be as clear and succinct as possible to the readers in this journal. So this here shows you an example of how to write the results, how to create a table, how to create a figure, and how to report those in a journal article. One final note before I end this series on moderation mediation is in deciding between mediation and moderation. Oftentimes you can be sitting there going, I know this is a 3rd variable, but I'm not sure if this is a mediator or a moderator. One way to kind of look at that, one is theory. The other way is to look at the actual values between the mediator and the moderator. So moderator variables are typically introduced when there is an unexpected weak or inconsistent relationship between predictor and criterion variable. So in other words, when the relationship holds in one setting, but not in another, or for one subpopulation but not for another. So when you see a lot of differing results in the research, it's indicating there's a moderator at play here. A mediation, on the other hand, is best done in the case of a strong relationship between the predictor and the criterion, so the predictor and the outcome variable. So this concludes the lectures on mediation and moderation, and you are now fully equipped to do moderation mediation analyses on your own and as you work doing structural equation modeling.